Okay guys, so the point of this video is you've learned about derivatives, you've learned the basic rules, maybe product, quotient, even chain rule, and now you're seeing all these problems and they start to get confusing because you don't know which rule to use. So we're going to talk through that. I've got 4 different examples here. On the first example, what I'm looking at is it's a fraction, and some of you might be tempted to use the quotient rule. However, what I'm saying here is that any time you have a monomial on the bottom, so if it's just one term involving an x, like a polynomial x, then I say the easiest way is to split this into 3 different parts and just rewrite the function before you even think about taking a derivative, okay? So if I were to split this up and then reduce, this new function becomes 2x squared minus 1 plus 10x to the third. This is going to be so much easier than doing a quotient rule. Now when you want to do the derivative, you're just going to power rule each term all the way across. So it'll become 4x minus 0 plus 30x squared, and to clean that up, I'll just write it like this. Okay, so much easier than a quotient rule. Now the second example is, what if you are given, I'll still use f of x because I'm boring, okay, sine squared of 3x minus 5. Okay, great. So with something like this, you might recognize, oh, it's going to be a chain rule because there is something stuck inside of these parentheses, and that is being applied to sine. But you might get confused on order of how to do things. Now remember, if there's an exponent here, sine squared, you can rewrite that first as the sine of 3x minus 5, and that squared actually pertains to the whole thing. Okay, so you can sneak it to the back of everybody, and this makes it easier to walk yourself through a chain rule because now you can see that this is actually like 3 levels. This is the outermost function, this would be like your middle function, and then this is the innermost function. So when I go to chain rule, I need to handle this one, then the sine, then what's inside parentheses. So how do I do that? Well, the derivative of something being squared is you bring the 2 to the front. Notice I'm recopying all this. It's now to the first power, right? Okay, so I've just handled my outermost function. Now I need to deal with what's the derivative of sine. Well, derivative of sine is a positive cosine, and then I'm going to recopy what I'm taking the cosine of, okay? And then the innermost layer, what is the derivative of that? So the derivative of that is just 3. So this, with all my scribbles, is going to be my chain rule that I had to do sort of twice. And now I'm going to put together what I can. I can only really combine these, so I'm going to call that a 6 sine cosine. And I can't really put those together because one's a sine and one's a cosine. So this is how I would write my final answer for f prime. I should have written that right here also. Okay, so number 3. Let's look at another example. Let's call this one g of x sine x 3x minus 5 squared. Now I did this intentionally similar to the last one, and I just sort of moved the squared to a different spot just so you could see the difference. Now the other thing that I did is there's now an x behind the sine. That's actually really important because the sine is no longer for 3x minus 5, it's just the sine of x, which means that this is I've got 2 functions being multiplied together. So this is, believe it or not, going to be a chain rule, not a chain rule, a product rule. It's going to be a product rule. And the way I always know that is if I have 2 functions that both have their own x term, that's when I'm going to do a product rule. So I'm going to call this guy f, and I'm going to call this guy g. I'm going to go out to the side of my paper and find their derivatives real quick so that I can work it into a product rule. So the derivative of f is just the cosine of x right? The derivative of g, now this one, I think it will be a chain rule. So and the reason I know that is I've got some mess raised to the second power. So I need to view this as this is the inside function, this is the outside function. So derivative of the outside part, well, something squared is just 2 times that something to the first. And then times the derivative of the inside is 3. So if I want to clean up g prime, it's really 6 times 3x minus 5. I'm not going to distribute that. I'm just going to leave it as is because you don't want to distribute it and then have to like factor it later. Okay, so what was the product rule? So you might remember that if I need the derivative of this function now, I'm supposed to do derivative of the first times the second plus the derivative, or the first times the derivative. I just mix it up. So you might have memorized it a little different, but make sure that you're mixing up the derivatives. It does have a plus sign in between. So my f prime is cosine of x. My g is this normal function, so 3x minus 5 squared, plus my f is just sine of x. And then my g prime is this business over here. So it's just good note taking and then putting it in the right spots when you rewrite it. The only way I would clean this up is with this 6. It looks weird being in the middle. So I would probably leave this one the same and then just move the 6 to the front of all of that. And I'd probably do it just like that. Okay, I have seen some people factor from here where they're like, oh look, there's a 3x minus 5 here and a 3x minus 5 here. I have seen that, so I'll do a maybe because this is just depending on your teacher or whoever wrote the test. Maybe they write it like this where they take out a 3x minus 5 and then that would leave behind a cosine x times 3x minus 5 plus a 6 sine x. So that might happen to you, but I don't know, it just depends. Okay, so here's your couple of answers. All right, so for the last problem, number 4, let's call it h of x. How about that? 2x to the third plus x over the square root of x plus 5. Okay, so with something like this, gross, you can't split it up because that's a binomial, okay? So I am forced into a quotient rule. So right off the bat, I'm going to call that f and I'm going to call that g, and I'm going to remember my quotient rule down here. Gf prime minus fg prime over g squared. So I need to find all these parts so that I can plug them in, okay? So if f is up here, f is the numerator, so what's the derivative of the numerator? Well, that would just be a power rule, so 6x squared plus 1. Now, the denominator is the square root of x plus 5. Well, the square root of x plus 5 is the same thing as x plus 5 to the 1/2 power. So when you do the derivative of that, it would be 1/2 of x plus 5 to the negative 1/2, and then times the derivative of the inside. It's going to be a chain rule because there's a whole bunch of stuff inside that radical. So the derivative of this stuff that's inside is just a 1, okay? And that would be my g prime. Now, when I write that out, if I clean that up, it actually looks like this. 1 over 2 times the square root of x plus 5, because it's got a negative exponent and it's got a negative fraction exponent. So this g prime, I'm actually going to rewrite it like this before I ever plug it in over here. I promise it looks ugly, but it'll make it easier when it comes time to simplify. Okay, so now we plug into all this madness. So for h prime, I need my g, which was the square root of x plus 5, okay, times my f prime. My f prime was a 6x squared plus 1, minus my f, which was that numerator right there, times my g prime, which I'm going to do the cleaned up version, 1 over 2 x plus 5, and that's all over this squared, the g squared. Okay, so the hardest part of these will be cleaning them up. This you can't clean up. It is what it is. Over here, I think what I would do is I'd go ahead and put those together because this is over 1. So you could just rewrite it as all of this over this. And what I have seen from teachers and on AP tests, I have seen where we try to get a common denominator, meaning all of this is over a 1. And we want to put all this mess together. So the denominator would be 2 times the square root of x plus 5. So what happens is if I make this denominator 2 times the square root of x plus 5, then I have to multiply the top by 2 times the square root of x plus 5. So this is me just doing a little common denominator math, and now on the next step I will clean that up. So what that means is that my numerator, my numerator will now be 2 times, now look, when you multiply these together, what ends up happening is the radical goes away, right? Okay, so this stuff in blue is me multiplying all of this. Okay, now I'm going to recopy my minus sign. Now the only thing in the numerator up here is this. Okay, and that's all over the common denominator of 2 times blah blah blah. Okay, so this is me doing a common denominator in my numerator. I still have this huge fraction bar here, and I still have this on the bottom. So what happens when I square that? Well, it just becomes an x plus 5. Now, for some of you, this is horrible because you maybe are weak at fractions and you never got good at this. Unfortunately, this is the year you have to get good at this if you plan on taking the AP test. You've got to be able to simplify this stuff. So what I've come to be good at is a 3-part fraction. I used to hate them. Now I love a 3-part fraction because when you do the whole flip the second and multiply thing, what ends up happening is a 3-part fraction, the bottom 2 parts come together. And so I know that when I do this math, I just need to recopy my numerator. Blah, blah, blah. Okay. And my 2 denominators come together on the bottom. So they just end up, being multiplied together is, I guess, what I should say. And that would be my simplified fraction. I mean, could you take it further? Well, if you're in a college math course, probably. They're probably going to actually make you multiply all of this out, then distribute the 2, then combine like terms. I mean, they could do that to you. I would say on, if you're in a calculus AP class, you're probably going to stop there and then start searching your multiple choice answers. Okay, so this stuff, it's not going to be easy until you practice it a lot. So doing 1 problem a day is not going to cut it. You're going to want to do probably 3, 4, 5 problems a day every day for a week or 2, and you will get good at this. Okay, so find a problem, let me know if you get stuck or you want to see me work one out on video. Thanks.